In this video, we're going to learn how to move from the solutions of an equation to writing the equation itself. And I want to start with the equation and then find solutions. So that way you can see how it's all connected. I've got this fifth degree polynomial. I want to know what are the values of x that will make the whole thing equal to 0. Well, there's this big theorem, a really big idea of algebra, called the fundamental theorem of algebra. It tells me that the degree of my polynomial will tell me how many solutions I'm going to have. And those solutions could be real numbers, they could be complex numbers, and those complex numbers are the ones like a plus bi or a minus bi. They could also be the same answer twice. So I could have that x is equal to 6 and it is a double root, which just means I've got this solution twice. If it was a triple root, I would have x equals 6, x equals 6, x equals 6. So that's what the degree is telling us. So this particular polynomial tells me I should have 5 solutions because it's a fifth degree. So what we're going to do to find those solutions is we're going to factor this, and then we're going to set each factor equal to 0 using the zero product property, and then we're going to solve each of those little equations to come up with the solution. So at this point, I want you to pause the video and just factor. Okay, so if you factored everything correctly, you came up first of all with the GCF of 2x, and the remaining expression was this fourth degree trinomial. This can then be factored. I used the AC method. A was 1, C was -4. I'm looking for factors of -4 that add to 3. I found that those were -1 and +4. So these are my factors of that trinomial. A squared minus 1 is a difference of squares, and these are the factors for that. A squared plus 4 is the sum of squares, and these are the factors of the sum of squares. Notice it has the I in them. So now that it's factored, we're going to set each factor equal to 0, and then we're going to solve each of those equations. So pause the video, set each factor equal to 0. So these are the little equations that we made based on the factors that we had, and that was using the zero product property. I'm now going to solve each of these equations to find out the value of x. Pause the video again, find the solutions of the individual equations. So I've got 5 solutions to this polynomial, and that does match this degree of 5, which told me I would have 5 solutions. Now, I do want to pay attention to these solutions right here. These solutions are imaginary numbers, and I could write them as complex numbers by simply putting a 0 in front of them. So now I have these complex numbers. They're opposite signs, so I've got complex conjugates. The complex conjugate root theorem tells me that if I have a complex number as a root or a solution, then its complex conjugate also will be a solution. So anytime I see an imaginary number as a solution, its complex conjugate will always be running around with it. That's important to know. So now we're going to try another example, but this time we're going to start with solutions and then move toward the equation. Okay, so now I'm supposed to write a third degree polynomial equation with roots of 0, -3, and 8. If it says it's third degree, that means I'm going to have 3 solutions. So I'm just going to start with 3x equals statements. If it says my roots are 0, -3, and 8, that means my solutions are 0, -3, and 8. I need to turn these into factors, so I could think of this as x minus 0 equals 0. That's just x. What am I thinking? I can't do anything with that. I could say that this is x plus 3 is equal to 0. I could say that this is x minus 8 equals 0. That's going to give me these factors, basically just x. That is going to give me x plus 3 and x minus 8 equals 0. So this is what my equation looks like when it's in factored form. I need to get this into standard form. So I could either multiply x times x plus 3, get a solution, multiply x times x plus 3, get a product, and then multiply that by x minus 8. Or I could group these two together and get a trinomial, and then multiply that trinomial times x. The order is not that important, so I'm just going to go ahead and start with these first two and see what we get. So I ended up with x squared plus 3x. Then I'm going to multiply that by x minus 8. You could use distributive property or the box method or whatever method you want to use to multiply that. So go ahead and pause the video now and multiply this out and make sure you combine like terms, and we're going to see what your standard form equation looks like now. So you can see on my work I used the box method to multiply. I ended up with x to the third minus 5x squared minus 24x equals 0. I do notice that this is a third degree polynomial. That's what I was looking for, third degree polynomial. So this looks good. I could check this on a graphing calculator or by hand, put 0 in for x. So this becomes 0 minus 0 minus 0 equals 0, so that's true. Put negative 3 in for all these x's and your equation should equal 0. Put 8 in for each one of these x's and you should see that the equation is equal to 0. But that's how we go from the solutions to the equation. I'm going to make another video that is going to have complex numbers as solutions, and you're going to see that it's going to make the multiplying a little more difficult, but we can handle it.